right, good morning, sixth grade. Happy Wednesday. I hope you're doing well. We're going to start by going over the follow-up question from last time. It says Jane paid $40 for an item after she received a 20% discount. Jane's friend says this means that the original price of the item was $48. How do you think Jane's friend arrived at this amount? Is her friend correct? Why or why not? So Jane got 20% off, a 20% off discount, and she paid $40. So if she got 20% off, that means $40 is 80% of the total item. And I'm going to do this by drawing a double number line because I think it's easier to see it this way. So this is what we know. If we split this by percentages on the bottom, 80% goes with $40. We want to know how much she paid for the whole item, which was the original price. So if I look on the bottom, I can see I'm counting by 20%. So I'm going to do that as soon as my pen works. 20%, 40%, 60%, 80%, 100%. And that means I need to have spaces for the same amount up here. So if I look, what could I count by that goes blank, 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 40? I could count by tens, right? 10, 20, 30, 40, 50. If this is the dollars, this is the percentage. So 100%, she paid full price, or the original price of the item would be $50, because a 20% discount shows us that at $40 she paid for 80% of the original item. So what is the original price? The original price is $50. Okay, let's continue. So I'm just trying to do like a review of different things, specifically with percentages. So I would like you to calculate each percentage here mentally, meaning using your head. You should be able to figure these out quickly in your head. I'm going to give you 5 minutes to do this. Go ahead. All right, let's see what we come up with. 25% of 400, 25% is like a quarter of, or 1/4 of the number. So 25% of 400 will be 100. Splitting it into 4 sections. 50% of 90, 50% is the same thing as taking a half. So what is half of 90? 45. 75% of 200, that's the same thing as taking 3/4 of 200. We can think about it a couple of different ways. The way I like to think about it is 50% of 200 is 100. So 25% of 200 would be 50, because I am counting 50, 100. So if I know it's split into 4 pieces, 50, 100, 150 would be 75%. %10 of 8,000, that's moving down a place value. That's dividing something by 10. So we could say that would be 800. And in case you do not believe me when you do this, a simple way to check is using a place value chart that you could do this. Obviously, you could use a calculator to do this, but we're just moving down to place value. This last one is a little tricky. 5% of 20, we know 50% of 20 is 10, that's half. 25% of 20 would be 5. So then what would be 5% would be 1. Think about the strategies you can use in your head, because these are percentage problems. You don't need to use double number lines or ratio tables. You can, but you should be able to do them mentally. Okay, let's start with our Buc-ee's challenge for today, playing video games. Funny, because although I don't think any of you have been to arcades, I do think you're spending a lot of time playing video games these days. So let's start with this problem. It requires 1/4 of a credit to play a video game for 1 minute. Emma has 7/8 credits. Can she play for more or less than 1 minute? Explain how you know. How long can Emma play the video game with her 7/8 credits? Right now, I would like you to pause and go ahead and take 5 minutes and write down everything that you notice and wonder. All right, here are some of my notices and wonders about this problem. It takes 1/4 of a credit to play a video game for 1 minute. Emma has 7/8 credits. 7/8 credits is more than 1/4 of a credit, so I think she can play for more than 1 minute. I wonder how many minutes she can play the games. What expression can I write to represent this situation? I'm trying to think in my head, what operation am I going to do that's saying how many groups of 1/4 can I have with 7/8 credits? So again, here is the problem. It requires 1/4 of a credit to play a video game for 1 minute. Emma has 7/8 credits. Can she play for more or less than 1 minute? Explain how you know. How long can Emma play the video game with her 7/8 credits? Now I would like you to pause and solve the problem on paper as best as you can. All right, so from the problem, we know 1/4 of a credit lets us play for 1 minute, and we have 7/8 credits. So let's just look at something for a second. If I draw a model like this, and I split it into fourths, she has 1/4 of a credit. She can play for 1 minute, 1 minute, 1 minute, 1 minute. So if she has 4/4 credit, she can play for 1, 2, 3, 4 minutes. Now, but she has 7/8 credits. So 4/4 is the same as 1 whole. So the only way that would be possible if she had 8/8 credits, which is also 1 whole, which allows her to play for 4 minutes. So based on the fact that she has 7/8 credits, we know she's going to play for less than 4 minutes. So let's figure this out. What if I draw a model? So I'm going to draw a bar model. And I'm going to split it into 8s. So we have 1, 2, 3, 4, 5, 6, 7, 8. I have 8 pieces. So these are each 1/8, 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, 8/8. So I know she has 7/8 credits. Okay, so she doesn't have a whole, so she's not going to play for 4 minutes. That's not possible. Okay, because up here, if this was a fourth, this is a fourth, this is a fourth, this is a fourth. These are the minutes. We're asking ourselves, how many minutes can she play? Okay, so let's think about this for a second. A fourth of a credit. How does that relate to eighths? So I'm asking myself, how many groups or how many 1/4 can fit inside of 7/8? Or how many 1/4 can I make with 7/8? So how are 1/4 and 7/8 related? Well, let's see. I know that 1/4 can easily equal 8ths. By setting it as an equivalent fraction and multiplying by 2, I know 1/4 is the same thing as 2/8. So I could, if I count off by 2/8, that's the same thing as counting off by 1/4. So let's do it. Here's one group of 2/8, 1/4. Here's another group. Here's another group. So what these groups are showing me is the amount of minutes. So far, since 2/8 is equal to 1/4, this is 1 minute. This is the second minute. And this is the third minute. So I know, because I'm counting 2/8, 4/8, 6/8, I know she can play for an entire 3 minutes. But now I have this extra piece. So I'm asking myself, what does this extra piece want to do? And I'm thinking, well, I'm counting off by groups of 2/8 or groups of 2. 2 pieces equals 1/4 credit, which is 1 minute. So I have one extra piece left. So this piece is worth 1/2 because it's one out of the 2 pieces that I'm counting by. So how many minutes can she play? She can play for 3.5 minutes. Let's look at this one other way. The other way we can look at it is making an expression. When I say how many 1/4 can I make with 7/8, that's the same thing as writing a division expression that's saying 7/8 divided by 1/4. We asked ourselves, how many 1/4 fit, or how many groups of 1/4 can I make with 7/8? So now, if you remember the algorithm, we can solve this. I keep 7/8 the same. I change the division sign to multiplication. And this second fraction here, I need to flip or take the reciprocal. So the reciprocal of 1/4 is 4/1. And now I'm going to multiply. 7 times 4 is 28. Oops. 8 times 1 is 8. Now I'm going to roll my numbers to see how many holes I have. 8, 16, 24. So I have 3. And then I have 24, 4 more to get to 28. So 4/8 left over. 4/8 is the same as 1/2. So either way I do it, I can see that she is able to play this game for 3.5 minutes. Either by doing it with the model or by doing it with the algorithm. All right, so what are our reflections from this problem? When we divide a fraction by a fraction, we ask ourselves, how many groups of one fraction can I make with another fraction? In this case, how many groups of 1/4 can I make with 7/8? To solve this problem, we can use a model to find out how many groups of 1/4 there are in 7/8. We can also write an expression and solve it by multiplying by the reciprocal. Here is the follow-up problem. Miss K has 1 3/8 cups of blueberries. She needs 3/8 of a cup of blueberries to make 1 batch of muffins. How many batches can Miss K make? I want you to think about the way I solved the video game problem using a model and also using the reciprocal method or the algorithm, and see what you can do with this problem. Now would be a great time to pause it and try and solve it. Questions. If you have questions about anything I discussed or have answers to the problems I left you to solve, please email me or Mr. Lengthy your responses or send us a message on Dojo. I will respond to your messages in my challenge for Monday. Have a great rest of the week. I look forward to seeing you all on Monday morning. Bye! At least for this video, you didn't cause any interruptions, but made yourself very comfortable.